Many students, obviously. I hope you can all sit down. So what I will do in this first lecture is first to give you an introduction on the course, and we'll talk about the practical organization so that you can see whether it fits your schedule and so on. And then we will already start the first lecture today. So I will already start the first chapter of the course. Normally, thank you for being here at 8:30. You see, I don't manage to start at 8:15, but I think nobody will complain, right? Hopefully. So at any time, please feel free to ask questions. I'm happy to answer. Even if you are many, no problem, we can deal with that. I will discuss the practical organization, but most of the lectures that I will give will be given in this format. So we'll start at 8:30, and I will not take 4 hours, obviously. I will not manage to teach during 4 hours in a row. So you can expect the course to finish after 11, but not really at 12:30 or at 12, right? We'll see how we proceed. As you see, the course is recorded. The lectures are recorded. So this introductory lecture will be recorded live. I mean, this will be this one of this year. And the other one, you will find them online. These will be the recordings of the previous years because I will probably not update enough the material to re-record and redo the preparation of the videos. So at any time, if you want to go deeper in some topic or if you missed something, just go to the videos and try to see if it's clear. If it's not, you just come back to me at the next lecture or you send me an email and we can always discuss, right? That also means that if for schedule reasons you cannot follow the lecture, that's not too bad. It's okay, because there will be the recordings of all the lectures. So just as an introduction before starting my part, I just would like to see who you are and whether you have constraints. I assume that some of you might have to leave at some point to go to other courses. So normally we have students from many different sections in the room. We should have students from electrical engineering. Can you just show me where you are? Electrical engineering? Not so many, yeah? Should be more, anyway. We have robotics, right? Yeah, as usual. Life science? And the rest, I don't know. Computational science, maybe, yeah? 1 or 2, okay. Other sections? Physics, very good. Other physics? No? There were other sections? Yeah?
Data science.
Pardon me?
Data science.
Data science, very good. Other data science students? Yeah, welcome. Good to see you here. And external students from EPFL, so students from UNIL? Hello? Anybody else? Okay, very good. So normally in the schedule of the EE department, at least, we have this lecture the whole morning. So who has scheduling constraints, scheduling problem? Yes, so you will have to leave what? For the second part at 10 o'clock, before 10 o'clock? Before 10 o'clock? Other constraints? Yeah? Everybody will, those who will have to leave for the 10:15 lecture, right? Correct? Yes? So again, the videos will be there for you. That's really why I made those videos. So no problem. If I forget to break, so you have your lectures at 10:15, right? 10:15? 10:15? Yes? So if I forget to break around 10, feel free to leave or just remind me that you have to leave and I will break, okay? Sometimes, in the rush, I keep going. Yes, please.
I'll just have to leave before 9:30.
So you are most welcome to leave. I understand. And I think nobody will complain, we'll have more air. No problem. I understand the constraints. It's out of my control. So I deeply apologize for that, but it's out of my control. Okay, so feel free, no problem. But you have to know, and that's why also this is recorded for those who are not here today, that there are a few steps that we will have during the course, and you might want to arrange your schedule so that those very important steps you will be present. I will give you more details in a moment. So let's see what we will see in this course. What I want to do in this course is to give you the basics of this topic of image analysis, pattern recognition, object recognition, shape recognition. So basically, image analysis, to make it short. Why do I have this? Okay. And so we will try to design to understand the methods that will allow you to design a system that will take raw data, images, and will give a result, the analysis of the content of the image. So it will be an automatic, it can be a semi-automatic system that will recognize the content of what is presented to the system. And we do that every day. I see you in front of me. I see how many you are. I can estimate globally. I can recognize faces that I know. I can try to learn faces that I don't know. So human beings are very good at doing pattern recognition. We will try to see how we can have a systematic approach of that for telling a machine to do the same or to do similar things. So that's basically what we will see in this course, and we will see a series of methods ranging from the most simple to the most advanced, say, machine learning techniques. This is not a machine learning course. This is not a machine learning course. It's an image analysis course, but we will see at some point how and when we might want to use machine learning techniques. Yep. Yeah, so that's what we are going to see, really, the foundations of this domain. You will see that I will give you foundations. I will give you basic methods. Some of them might be pretty simple. This is really on purpose. I want you to learn the basics so that at the end, you can take a more advanced paper in the literature, read it, and understand how it is organized and what are the foundations of what you see in more advanced methods. At some point, I will also see advanced methods. But really, I want to have more like a structural approach where I give you the big blocks of what you need to know to understand almost any image analysis technique that has been published, right, or used. So hopefully, at the end of the course, you will see the structure of how to build a system and know the basics of the different blocks. That's my goal. And just to give you an example, we are very good at that because when you see that, even if you don't speak French, you recognize that at some point in time, a baby was born. Kind of, because of the drawings probably. And then you read and you say, aha, there are first names here and here. And then you try to understand the structure of this, and even if you are not French-speaking, you kind of see that there are two first names, and if you look carefully, this is the first name of the baby, and this is his brother, and you have a birth date sometime. Wow, he's already 20 years old. Wow. Every year is, yeah, okay, anyway. And so you recognize that. Now, just try to see what I just did in, 15 seconds? To explain what I recognize there. Just try to imagine how you would teach a machine to do that. You have pixels. What you see is basically black and white points. And from that, you have to tell a machine, well, try to see what you have in this picture. That's not that easy, right? You will have to recognize that they are pieces of groups of pixels that mean something, and then go further and further in the analysis. At some point, you might want to do feature extraction. At some point, you might want to do machine learning. But just try to imagine the complexity of this task. And what I want to do with you is try to divide this complex task in more simpler blocks so that you can really take one after the other and take the right methods, or at least understand the right methods to achieve the goal at the end. We will never do that in real, but it's just to tell you that what looks very simple to you, we need to structure that to understand, okay? And at the end, you have the answer here. So, other examples. We will not do speech recognition here, but this is a typical example of pattern recognition. You have a signal that represents an acoustic wave at some point, acquisition, and then processing to recognize. This is a typical pattern recognition process in a 1D signal. You have a lot of that in the industry. We receive every day in the lab, not every day, but almost every day, visitors from industry willing to do image analysis for their production. This is an example of an industrial production in mechanics where they had to weld pieces together and they want to assess the quality of this work. And it seems that sometimes, you probably even don't see it, there are defects in the process, and they want to have a quality control. We have that every week at least. This week we had visitors willing to do that from the watch industry, for instance, analyzing the quality of small pieces. And they always come and say, aha, I heard about machine learning. I want you to tell me if we can do that with machine learning. And I say, tell me more about your problem. Machine learning is not magic. You have to go back to the basics first. And that's what we will try to see. Biology, lots of images are produced by fantastic microscopes. You need to analyze them, at least to have tools to extract as much information as you can before presenting that to the expert. Because if you want to do large screening of whatever you want, pre-processing help is needed. So biology is a large field of application of machine learning or of computer vision, of image analysis in general. Autonomous vehicles, they are coming. They are coming very strongly. They are full of image analysis. For the outside, to guide. For the inside, to monitor the environment, to monitor the driver of the guy who is supposed to drive one day. So this is really coming very strong, and this is full of image analysis. Surveillance, security. This is a very old project that we did maybe 20 years back to try to detect fires as soon as possible, as early as possible. Imagine that you have smoke detectors. We're supposed to have smoke detectors. If there is a fire here, it will take a while for the smoke to reach the detector. Video could help in some very critical cases. That's something that you can do. And then you have medical imaging. Medical imaging is my field of research, so I like to talk about it. And that's a domain where image analysis is also coming very strong. For many, many, many years, since the foundation basically, medical imaging was really the idea of producing an image that an operator can read. And this is not the case anymore. We produce images that are first processed by computers to extract information that an operator can read. So in many situations now, the things that we want to extract from those images are so subtle, so hidden, that you need really advanced methods to extract and detect them before presenting the result. This is an example of a pathology called multiple sclerosis, in French, la sclérose en plaques. And to assess the level of progression of the disease, we have to analyze the amount of, you see them here in green, the amount of lesions that you have in the brain. And this is an extremely complicated task because some of them, you see them clearly. Oh, by the way, these are two images of the same brain with different contrasts, different types of acquisition in an MR machine. Doesn't matter really. We will come back to that example later in the course. But you see some lesions. They are here. This is this one. Okay, you see the big ones. But you would like to have a computer telling you exactly how many square millimeters or millimeters cube the lesions are, just to give a precise number and see how the lesion count progresses. Okay? So this is also a field of extremely important growth in image analysis. And therefore, what we are going to see is really how all those examples can be structured with the same approach, which is the classical approach to do image analysis and pattern recognition. And at some point, I will branch to tell you where the most fancy, advanced methods will play a role. But you will see that all the time it follows the same principles. And this principle is the idea of having a system where we have an input, which is the raw data. And I will most of the time say the stupid pixels. I think you will remember this term. The input is the stupid pixels. A pixel is really stupid. It's black and white or a color value somewhere in a matrix. There is no information there as such. But the collection of those stupid pixels make your image and make the content. So we will start with those raw data, the stupid pixels, and we want to come out with ultimately what we will call a decision. Whatever it is, we will try to extract information to drive a decision at some point. It can just be present information to the operator, but it can be take a decision and control a robot or define a diagnosis. So it can be quite a lot of things, but always we have in image analysis stupid pixels at the input and clever decision, more or less clever, decision at the output. And that's really the chain to go from X to Y that we will see. And this chain, I will show you now for the first time, this chain. And at the beginning of each of the lectures, I will show you again the same drawing. So hopefully you will remember it, because it will be always the same. And it's also the table of content of this course. So we start with the sensor. We will not do here descriptions of sensors. We will not do electronics. We will not do CMOS design to do the sensor for the camera. We assume that we have a sensor coming from somewhere, and this sensor gives stupid pixels. So here I have stupid pixels. And then there is a series of steps, 3 blocks, that we will have to do to come to a decision. And so my stupid pixels are here, and my decision is here. And in the middle, you have 3 blocks. And whatever you consider, independently of the method that you consider, independently of the application, in the vast majority of them, you will have those 3 steps that you have to follow to convert your stupid pixels into a decision. And again, even in the machine learning techniques in computer vision, this structure is there, hidden in a neural network, but it's there. So to really understand all this, you need to know those 3 blocks. And basically, that's what we are going to do. Here, we are not going to consider that because this is the domain of electricity, of electronics, of metrology. But we are going to see how image processing techniques can allow us to convert those stupid pixels in something here that we will call objects, which are groups of pixels of interest. And when we have those objects, now we come with the shape of those objects and we have to analyze it. So basically, from stupid pixels, we go to objects. From objects, we will go to features. So we will describe the objects. And we are talking about topology, geometry, and we'll have a lecture on that. And then from features, we go to decision by a classification process. And that's where AI comes in the game. Okay? And so at the end, we have a decision, and we can give that to the next step, a robot, an intelligent system, diagnosis database, whatever. And so that's basically what we are going to see. First chapter, we'll have a series of lectures on that, 2 lectures on that, then 1 lecture on that, and 1 lecture on that. And in the middle, we have a bit more, but anyway. And then, altogether, we'll have this 2 by 2, 2 plus 2 format. But as you can see, I will group the lectures in one morning, like we will do today. And I will show you the schedule of the course, just about next slide. So I will not have 2 hours of courses and 2 hours of exercise at each lecture. We'll group and we'll have a kind of an original organization. I will show you that in a moment. In particular, we'll have 3 labs, 3 simple labs that will cover those 3 blocks. And then the second part of the course will be, okay, your turn now. You learned something. Try to show that you can use it. And we will have real problems that I will ask you to solve within what I'll call a special project, which is a mini project in the framework of the course, where you will have time to really realize a system by your own and present it to us at the end. So basically, we'll have a continuous evaluation. There is no exam at the end of the course. So there is no exam during the session. This will be a mix, a weighted sum of the different components of the course. The 3 labs will count for 20% of the mark. So I will ask you a report. You will work by groups. And I will wait a little bit more to define how many people by groups, because I know that some people might come in the course, might join the course, hopefully not too many. Some of you might leave the course, that's live. And so I need a little bit more time to define exactly how we will organize those labs and the special project to see how many of you will really register to the course and will need a mark. But at the end, I will ask each of you to give me a report for each of the 3 labs, but it can be the same report for the different members of a group. So I will ask you, and I will keep repeating that, each of you will have to upload a PDF on Moodle, each of you, but it can be the same PDF for the 3 members of the group if we work by 3. Clear? So, but I will need a PDF by each of you. Upload it manually. We understand each other, right? And this counts for 20% of the mark because it is basically 20% of the amount of time you will spend on the course. Then we will have individual meetings. I also call them interviews. To make it clear, it's an oral exam, but I like to call it interview. And that's basically 1 or 2, again, depending on how many you will be, 1 or 2 individual meetings with me in my office where I will ask you questions about the lectures. So I will ask you to basically show me that you understood what I tried to convey to you during the end lectures that we'll have together. And that will be, depending again on how many you are, a 10-minute interview, very fast. You have to be well prepared. It will be too late at that time to open your slides and say, can you repeat? That's too late. 10 minutes goes very fast. It will be 1 or 2 times 10 minutes, depending how many you are. I will tell you more about that. But this corresponds to the amount of time that you will spend in my lectures, which is basically 40% of the course. And the rest is the final presentation of the project. So, more details. This is the schedule as far as I can see it today. This is on Moodle already, so you can have it there. So we are here, and you see, for practical reasons, sorry for that, for the lectures, we will always start at 8:30 here in ELA 1. This week and next week, and with that, we will already cover the first block, segmentation, today and next week. So we will have this block, so it will be possible for you to have the first lab on segmentation in March 6th, and the room is CO23. This is something that, again, next week I will give you more information, but this will be by group of 2 or 3, most probably 3. And it's a practical application of what we will see this week and next week. And I will ask you to give me your report for that lab before lab number 2. So on Moodle, there will be a deadline at 8:30 on March 27 for uploading your report for lab 1. Okay? So in the report, I will expect you to really present what you have tried. You will see for a given problem, there might be different ways to approach it. You might go by trial and error using the amount of information that you received in the lecture or that you can find anywhere else. And so I don't expect you to give me one final number in the report. I ask you to explain what you tried, what are the discoveries that you did when you tried different things, what did work, what didn't work, to come to something that gives the right answer. But I really don't care about the final answer. I care about what you tried and why you tried and what you learned when you tried different methods. And we'll continue this idea for the next. So we'll have a lecture which is a little bit different, which is kind of an outsider in this process, about a pretty advanced segmentation method. This is called active contours. It's a nicely mathematically designed method called active contours, and I will have a full lecture on that, but there will be no lab about that. And then we will have the lecture on the second block, object description, followed by the lab on object description. And again, I will ask you a report before the beginning of the next lab. Third lecture, well, fourth, but third block, classification. The basics of classification, statistical classification, lecture and lab. And then we will already be at Easter, so I think you have 1 week off, if I'm not wrong. I think it's that week. And then the second part will be special projects. That means that at the first lecture after the break, we will come and introduce what we expect from you. And then you will have to work again by groups to realize this special project. It will be a project about image or video analysis. It will use the tools that we will have. It will use most probably, yes, certainly even machine learning techniques that you will have learned earlier or that will be presented at the beginning of that part. And very practically, you will have to develop something and present it at the end. So that will be the second part. So much more freedom in terms of scheduling of your calendar, but constraints to present something at the end. For all of them, for all the mandatory steps, what are the mandatory steps? Well, you have to do the lab. You do it how you want. There will be assistants, TAs, in CO23 to help you. If you come, fine. If you don't come, I don't care. So for that part, you are free. You do it in the lab and you seek for the help of the TAs. You do it by your own somewhere in SAT. I don't care, okay? But I expect an upload per student by the deadline, very clearly. Yes?
I was just wondering about the third lab because it's on Holy Friday and the Easter break.
Is it?
Yeah.
Shit. Oh. The what? The third one? That one?
Yeah.
Is it? So I made a mistake there. This schedule will be revised. It will be hard to convince my TAs to come anyway. Sorry for that. I missed that. I thought I would only have 1 day off, but obviously it's 2, so I have to revise my schedule. Sorry for that. So also for those who follow on the recording, this will be revised, okay? You can expect an update from me by next week. But at least next week we have the course, okay? Thanks for this. So what is mandatory is to give me a report for each lab. Is to be there for the final presentation. I will be flexible for the schedule for simple reasons that I cannot fit all of you in the 4 hours of the Friday morning anyway. So for that one and for the interviews, we will work by doodle. So I will set a doodle with more slots than the Friday morning, and we'll see how it will work. It always works like that. So working with doodle really works well as long as you play the game, as long as you check all the boxes where you are available and not only the most convenient for you. Okay? So you will have to check the boxes that are possible for you for an interview or for the final presentation. And with that, we will manage to cope with the constraints of all of you. But I really ask you to play a fair game. Don't check only one because it's a Friday and it's not too late, so you can go back. Okay? I really ask you to play a fair game and check the boxes where you can make it so that we can ultimately cope with the constraints of all of you. Okay, questions on this schedule and on this organization? Except the Holy Friday. Yep.
Is a special project, are we graded on the presentation alone? Do we have to
No, it's the content, of course. It will be the content of the project. So there will be no intermediate step, no midterm or something like that. So it will be only on the final presentation, but there will be a little report, and the assistants will also help seeing how you worked. So it's really the content. It's not just the way you present, of course. Okay, yeah?
For the special projects, do we compose a project ourselves?
No, it will be the same objective for all of you. And it will be, hopefully, we change every year. So we are still in the process of fine-tuning what we will ask you. But it will be practical. You will have images or most probably a video sequence or series of video sequences. You can receive many of them before to try. And at the end, you will have to realize on an unseen video. It's like those international contests that you can practice before with toy examples. And at the end, you have to show something on real data. And that's where the stress comes. And that's where I can check whether what you did is robust or not. So we will try to organize something that in a fair way. Don't worry, it will be nice. And hopefully, you will have fun with that. When you were not so many, I used to use real robots that you had to guide and to program to do something real based on a camera. Unfortunately, I don't have enough means and enough TAs to deal with 150 students, each of them having a Lego robot which costs 1,000 francs, something like that. So one day I will revise that. I think this year we will work just with videos, which is a bit cheaper. Yes, please.
Do you have to have previous experience with Black Lives Matter?
Okay, it was written somewhere and I forgot to mention. Historically, the language that we have used for the labs at least has been MATLAB, but I really, really encourage you to switch to Python. We will use Python and Jupyter notebooks. So giving your reports might just be uploading your Jupyter notebook. I'm absolutely happy with that. If you want to convert it in PDF, that's okay. It's less easy for us to run it, but that's okay. So I really encourage you to switch or to use Python and Jupyter for this. But if really, really, really you don't know anything about that, MATLAB will be okay. But we will provide little support because the TAs will basically work with Python, but we can. So who is really very uncomfortable with Python? So maybe it might be a good idea. My suggestion is that you decide because you are allowed to decide. But my suggestion would be to join a group who knows already Python so that you will learn a little bit of it. So that's my suggestion for your future, not for the short-term grade that you will get. It might be simpler for you in MATLAB, but my suggestion would be to really put your hands on and try to use Python within a group who knows how it works. That's my suggestion. You do what you want. Yes?
So if the first lab is assigned on March 6th, and then it's due a couple of weeks later?
The first lab, what?
It's
March
assigned,
6th, yeah?
And then it's due at March 27th?
Exactly.
Yes. How can we get questions answered if we have questions after that first lab?
You will know the TAs, you can contact them.
Okay.
So we will probably not have office hours that strictly, but they will be around and you can contact them. So they will be there at the first lab. Their coordinates will be on the Moodle. They are not yet because they will organize themselves by subgroups of TAs, so I have to figure out how to do that. But you can really go back to them. And if we have many requests, we can organize office hours. We can say that, well, at any time we will see. Or it can be by Doodle again. So that's an important message. Do not hesitate to ask the TAs or myself for more. So you are many, so it's not that easy for us to handle, but if there are consistent requests, we will handle that. That's really how we did for the video, for instance. I was not prepared to be recorded, but it was so impractical for many of you to attend the lecture that we decided to record it. This was a bottom-up approach. More questions? You want to stay? Oops. Cheers. So you want to stay? Yeah? No choice at this point. So let me finish my introduction, and then I will have a first break. So those of you who have to leave can already leave. I have one more slide, or two maybe. So if you want to buy books, you are not obliged to. But if you want to buy a book and want to know more about pattern recognition, I really suggest this one. This is an old one. It has been revised over years. I don't change the picture. But the book of Milan Sonka is a kind of a reference textbook on image analysis. It doesn't include the most advanced techniques, but it's a very good book for the basics. Okay, so you have the Moodle. I guess all of you are officially registered. You don't need the enrollment key, right? But if for any reason you would need, or you would have a friend who would like to access the course material, there is an enrollment key. So that's for those who do not have this course in their official program, but still want to join the Moodle. There is an enrollment key that they can use to access the Moodle without being officially registered in IS Academia. So you will find the material. I assume that you all have access to the Moodle and that it works. You have the slides. So that's how we will work, right? Okay, finish quickly. We do in the lab image analysis, medical image analysis. So the methods that we will see will allow you to design a system that will extract information from medical images. It doesn't work, so it doesn't matter. To really do computer-assisted surgery, to do computer-assisted diagnosis. So these are things that we have been working on for years, and they are really, really extremely interesting examples of image analysis because really it gives an impact. And what we did in the lab has been transferred to the clinics, and some of them are commercial products today. So this is really a straightforward path from the design of the method to the real impact of it. And it can be applied to very strange, for the patients, very strange images, patients with large tumors. Can we still have nice definition of the structures to quantify the structures of the brain? This also applies to computer vision, face recognition, facial expression recognition. This is a work that we did several years ago to track the face. You don't see it because it's an infrared image. You kind of probably can see or not that there is a face there. And this is a typical image analysis pattern recognition problem. We have a face tracker that we define, and then we extract key points, and based on the geometry of those key points, we give an estimation of the facial expression. And this has been very much developed in my lab, and when you will go back after the course to that example, you will indeed recognize that there are different blocks where we extract an object, when we describe it, and when we classify it. And this can be done at any point with traditional or machine learning techniques, and we will see what are the reasons for choosing one or the other. They are very good reasons, not only because it's trendy, but very good reasons for choosing one or the other. And this has been also transferred to the, in this case, to the car industry, because we had collaborations with car manufacturers willing to monitor the state of the driver. So whether the guy is tired, but also whether he's stressed, whether he's distracted. And monitoring the driver is an important topic in the automotive industry today, within the transition from manual to autonomous vehicles. And for instance, we had a stress detector that was a very nice demo that we had on people stressed when driving, and you had a stress level like that. And at some point, there was a nice music starting to say, okay, cool down. And the effect was that it was actually more stressful for him. But that's another story. Yeah.
How robust is your stress detector?
The phase detector is something very well known today. Detecting a phase in complex images is very well controlled. And we will see not how it works, but we will see the basics of that. And the reason is that this is a domain where we have plenty of examples that are nicely annotated by you on Facebook. And so people have been able to build very robust phase detectors because of you. And so machine learning needs data you provide them, and you tag the faces, so they are able to do detection and then recognition very robustly. Okay, that is another project that we are working on today. We created a startup, actually. It's very practical, but it's a system to count the waste on the road, to give an index of cleanliness for a city. How clean is my city? And so it's a system that uses a simple camera, and we built a system to really recognize all the waste that you have on the road. And you see it is mounted on those cleaning brushes where they collect the waste. And with that, we can map an entire city after one day, saying how clean it is before and after cleaning, and optimize the cleaning process. And it recognizes the cigarette bits, it recognizes the leaves, it recognizes the McDonald's caps and things like that. So this is practical stuff, but it's applied machine learning, if you wish. Voila, that's my introduction. After the short break, I will start with the first lecture. Do you have questions on the introduction before we break? Is my organization okay except the Holy Friday? So I guess I will have to shorten one of the days for the special project. That's life. We'll see. We'll see. Okay? Thanks. Let's have a break, 10 minutes, something, and then we start the first lecture.